Hello everyone, I would like to welcome you all for Linux administration course from Edureka. My name is Sarun Kumar. I'll be the instructor for this course. So before starting today's session, we'll have a quick introduction about each other so that that would be helpful for me in taking the session accordingly in helping you with your doubts and all those stuff. Okay, so before in the meanwhile I gave an introduction about myself. You can quickly give a one-line introduction of yourself as well. You can type it in the question box that you have. All right, so about myself, Saran, as I've said, I have around 8 years of experience training people on Red Hat Linux, scripting, etc. And I also have hands-on experience as a Linux administrator. I've been part of uh, multiple projects in different areas of Linux administration or system administration. All right. So, okay, let me quickly read the introductions that you have given. All right. I could see we have around 5 participants today. So uh, they are Rahul, John, Vijay, Karthik, and Priya. Welcome everybody. Thank you for uh, mentioning your introduction part. So we have people from different backgrounds here, and there are people who are very new to Linux operating system or Linux administration, and we also have people who have some experience working on Linux systems. That's good to know about you all. So we'll go at a more medium pace so that I'll ensure that so everyone is in sync. Okay. So at any point of time, if you have any question in your mind, feel free to post your questions in the question box. Okay, I will keep it open in front of me, and whenever needed, I'll try to answer your questions, and then we'll gradually go through the topics for the day. Okay, so before starting the course, I would like to quickly talk about the LMS portal. I hope you all have received the credentials, right? So this is a live instructor-led course, okay, which is a recorded session. The session will be available for you for your reference. It will be made available in your LMS in the next 24 hours, okay? And with every module you'll have a presentation which is also available in your LMS. There are assignment topics available which you have to finish and submit back to us for so that we can review it and see how you are performing. All right, and we also have a project which we'll be doing in the last module of this course. Okay, and so you'll be asked to do a live project and submit it back to us, and once we review it, we will be giving you a certificate. So that will be a certificate from Edureka that you have successfully completed the course. Okay, so other than this, we provide 24/7 support. So whenever you have any question regarding any of the topics, you can always, so other than the time you don't have the session, you can send your queries to support at Edureka. Okay, the support team is always available to help you with your queries, and if necessary, they'll route those requests to me. I'll be sending a response to you as soon as possible. Okay, so let me also uh, show the portions, show these sections in LMS. So I hope you all are seeing my screen. Okay, so once you open Edureka with your credentials, you can see here, it says courses. Click on my courses, and here you can see, click on go to course, and now you can see here there are a lot of sections available with a lot of information. In fact, before attending a session, you can always check the pre-recorded classes here. Okay, so all the recordings which were done in the previous batch, they are made available in your LMS. You can go through those recordings and get ready for the class. Okay, and you have all the presentations made available here. We have also provided the installation guide on how you can perform the installation in different operating systems. So for every module we have a section here, so click on any of the section and you can see the presentation over there. There are some quiz questions for you, and there is an assignment, and the class recording will be uploaded here. So you can see here, right? So this is available for you in the next 24 hours. You can always log in into LMS and go through the recordings. Okay, and we have also provided the assignment solution for your reference. So these are the two tabs that are available here, and if you have any questions about the LMS, so we have a separate section. You can go through that section in order to get used to it, and how the classes are being taken care of. All the options are available here. Clear? So that's pretty much about the LMS that I wanted to show you. So always by the end of the session, just one more point is you would have a feedback page. So please provide your feedback to us on how the class went. It will always be helpful for us in order to make the class much better for you. Okay, so let's get started with the first module of Linux administration course. So here, these are the list of topics that we have as a part of the Linux administration course. So starting from the installation and how to perform the installation, I'll be giving you a quick demo of how to perform the installation process, and then we will go through the different other features or options that we have, like package management, how to handle the packages, how to perform installation, how to install software in a Linux system. Okay, and then what are all the processes that are running in the system, how to check the processes, how to stop or start the processes, and a lot of other details with respect to processes, like what is the memory consumption of the processes. So every process consumes system resources. So we'll do a deep dive into all those areas in the second module. Okay, and in the third module we'll focus on the other services that are available, the different utilities that are necessary for Linux admin in the day-to-day job, and then there are a lot of important configuration files, all right, and the corresponding directories available. So we'll focus on those areas in module 3, and in module 4 uh, the topic is system services. So here a lot of important stress will be given on installing the services, stopping the services, and other related configuration information will be included here. Okay, then module 5 is about user administration, where you would learn how to create users in the system, how to delete users, or there is a lot of information associated with the user, like a user can be a part of a group, right? So we'll see how to create those groups, how to add the users to groups, how to remove the users, and there are a lot of other attributes associated with users and groups. So we'll learn how to change or make changes in all those areas. Okay, and module 6 is about file system security and management. We'll focus on what a file system is, a Linux file system is, and what are all the features that are associated it, and how to manage Linux file system in module 6. Similarly, in module 7, it's an advanced level with respect to the file system management. Then in module 8, we have server configurations. So as a part of Linux administration, you would also be learning on how to configure different server configurations. Okay, so we have topics starting from DHCP service, DNS service, okay, Samba service, like that. There are a lot of server configurations which are part of this syllabus. Okay, so we'll focus on each of these server configurations, starting from uh, the importance of each server, so what it does, what are the services it offers, okay, and we'll gradually go into the configuration part, how to configure those servers, and then a little advanced with respect to security, how to enable the security around these servers. So we'll do a deep dive into all these areas with respect to server configurations. In module 9, you will see topics like shell scripting and purpose authentication. So this is shell scripting. I hope you all have heard. So it's all about uh, the automation. There is a bash. If you have heard about it, we have a bash scripting or shell scripting. So we write a few scripts. We go through all the topics related to the scripting, different functions that are available, how scripts will be useful for Linux admin. So we'll also try to write a few scripts. Okay, and then we see the Kerberos authentication. So it's a different authentication mechanism that we have. So we'll see how to configure that in a Linux system. So now in module 10, again we have few more services like Samba service and a mail service and virtualization. So if you have heard about virtualization, how to create virtual environments. Similarly, I mean, I hope you might have seen that in Windows. We'll follow similar topic in a Linux system. So what are all the different types of virtualization available, how to do the virtualization, how to install another operating system, a virtual operating system in your Linux system. So we'll focus on these areas in module 10. Okay. In module 11, we have advanced security and networking concepts. So though the security part, so the there are I mean, we'll start in the initial stage itself. I mean, in first four modules we'll start the initial stage of the security will cover some basic things like the permissioning and all in the first four modules, and then gradually we'll go to the next level of security, and in module 11 we'll go to the advanced level of security, which covers SC Linux, security enhanced Linux, and then topics related to firewall, okay, on how to configure the firewall. So these are all the topics in module 11, and we will also focus on the networking concepts like how to configure your system, or how to make sure that you have two or more systems created in a network. All right, and some of the areas like how to troubleshoot if you have any issues with respect to your network. Okay, so these are the topics which will be covered in module 11. And in module 12 we have database configuration. So all these topics which are part of the course, they are in line with the course syllabus that is there for Red Hat Certified Engineer RHCE. So even a database configuration is also part of the syllabus. So where you will be installing the database, performing some basic operations by connecting to the database. So that is what would be covered in module 12. In module 13, we'll see how to do IPv6 configuration. So far you might have heard about IPv4 configuration. So here in module 13, you'll learn about IPv6 and also something called Kickstart installation. So Kickstart installation, to say in short, it's an automated way of performing the installation. So if you have been asked to install Linux operating system in some 100 machines, okay, so obviously you're not going to sit before every system and perform the installation. It's going to take days, right? So here what we do is we automate this process. Okay, so there is a way, we call it as a kickstart installation, which will automatically take care of installing the Linux operating system in all the machines. So we'll see how this can be done and there is a file corresponding to it called as kickstart file. We'll see how to create that file, what are all the options that are available. Okay, so with that we are done with all the topics. Just an introduction about all the topics that we'll be covering, and the module 14 is about the project work. So you can see, right, there are a lot of bunch of topics that you'll be learning as a part of this course, and you'll be doing a project work that includes all these topics, different questions that covers almost all of the topics that you would have learned by that time. Okay, so that's how the course has been designed. So today I'm going to talk about uh, first module, which is about installation and initialization of Linux operating system. Okay, let's get started. So as a part of module 1, so we'll see how to do the installation process, and I will also give you a quick introduction about what a Linux operating system is. So people who are very new to Linux, or people who also have some experience on Linux, there are some areas, some basics or the fundamentals that you should be aware of. Okay, so as you uh, work on a Linux operating system, so an understanding of these areas would definitely be an add-on for you, would help you a lot while working with the system. So I'll give you an introduction about these topics, and so which is about the architecture, the boot process, and a Linux kernel. Okay, so then we'll see how to work with the Linux system. So there are two different ways. One is the graphical way, and the other one is the command line way. Okay, the black screen with small prompt that you see. So we'll quickly switch between these two, and start performing some commands, running some commands, and interacting with the operating system, and see how it works. Okay, so then we have a quick introduction about the bash shell. I'll explain you what a shell is, what are all the features of shell, and what are the different types of shells that are available in Linux. Okay, and followed by that, so I'll show you the different ways and in which you can start your system, what are all the different targets that are available. Okay, so that would be the last topic for today. So let's first start with the Linux architecture part. We'll see what a Linux system is, okay, followed by the boot process, and then we'll focus on the installation part. So what is a Linux operating system? A Linux, so you all must be pretty much aware of Windows and other operating systems available, so which are commercial in nature, but Linux is a free and an open source operating system. So you can get the operating system for free. You need not have to spend a single rupee for it. Okay, and there are a lot of important features that are associated with Linux operating system, starting from portability, multi-user, multi-programming. You have a shell security, and there is a hierarchical file system. So there can be, the terminology here, we have used a lot of words, so which might be a little confusing for you, but I'll be, as we progress from one section to the other section, we'll have these words coming up every time. So I'll give you the meaning, I'll give you some examples of understanding each of these things. All right, so you need not have to worry about it. So Linux is a broad term. All right, so it's like an umbrella under which we have different distributions of Linux available. Okay, so currently we'll be performing all the operations using CentOS 7. Okay, so CentOS and Red Hat both are the same. Okay, so with Red Hat, under the name of Red Hat, they provide commercial support. Okay, so all the organizations so who want to have their applications on a stable Linux system, they would also be expecting some support. All right, so that is where they will be using the Red Hat version, and the same one without any support, we call that as the CentOS. Okay, and other than Red Hat and CentOS, we also have other flavors or distributions like Fedora. Ubuntu is also a very good one. So a lot of people use Ubuntu as a desktop version. Just like Windows, you can go with the Ubuntu also. There are a lot of good features associated with it. Like that, there are more than 100 Linux distributions that are available in the market. Okay, so the main thing here is, so when I say Linux, you can imagine Linux to be the kernel. So this central part. Okay, so we'll see what a kernel is, but the kernel will be the common part here, and around this kernel they have also each distribution would have added different applications, utilities, etc. So that is how we have a lot of flavors. Even you can get the kernel. So when I say Linux is free, it means kernel is free. You can go to a site called kernel.org, from where you can download the latest kernel, come up with your own applications and utilities, combine them, and uh, name it as your own distribution. All right, perfectly allowed. So as I've said, so Red Hat is the commercial one with commercial support. So RHCE is the certification that Red Hat offers, Red Hat Certified Engineer. Okay, and whereas the CentOS is the open source part. Like that, we have a lot of distributions. Okay, I hope this is clear. So if you look at this picture, all right, so you have the central part is like your hardware, and you will be having your kernel. So the kernel is like the heart of your operating system. So that is the next level. And around the kernel, we have shells. So a shell is an interpreter. So whatever commands, as a user, whatever commands that you give to the computer, okay, to the system, so the shell will interpret those commands, convert them into a system understandable language, and so it will be sent to the kernel, and the kernel will take appropriate actions, and the output will be again printed on your screen with the help of kernel. So kernel is like an interpreter. Okay, so using the shell, you will be interacting with the kernel. Okay, and apart from these two, we have utilities and application programs. So there are a lot of utilities available using which you can achieve a lot of things in Linux. And then you have application programs, means all the programs that you see when you log in the graphical mode. Maybe that way it will be easy to you to imagine or picturize it. So all the programs that you see in the graphical mode, you can imagine that. So they are externally added to the entire operating system. Okay, like that, we have different sections. This is how it is, the Linux architecture is. Okay, moving to the next slide. So as a Linux, I mean, being a person who is working on a Linux system, all right, so it is important to have an understanding of Linux boot process. That means the moment you switch on your Linux system, all right, to the moment where you see your login prompt. I mean, the system asking you to log in by providing your credentials. So there are a series of steps which are involved in between these two stages. All right. So where you have switched on your system and to the point where you have been asked to log in. So an understanding of these stages is essential for Linux admin, or it will help you as a Linux user. It will help you, it will give you a good understanding of how the system works. So these stages altogether are called as booting process, boot process, or booting process, Linux booting process. Okay, so I'm going to quickly talk about these the stages of the Linux boot process. Okay, so in case if you have any confusion, just feel free to post your question. Okay, so I'm seeing so far there are no questions from you, so I assume that we are good so far, we are in line so far, right? Just could you please give me a confirmation? All right, thank you. So Let's start with the moment you have uh, powered on your system. Okay, so the moment you switch on, what happens is there is a device called SMPS. Okay, so which converts the AC power to DC power. Okay, you basically so that's what first happens. The power will go to SMPS. It will get converted to DC, and all the devices, if you have seen uh, inside your computer, all the devices or which are connected to the motherboard, okay, all these devices, the DC power will be sent to all these devices. Okay, and the most intelligent device is your the CPU. So CPU will have a small memory which contains a series of bunch of steps. Okay, so what it does is as soon as it receives the power, it will try to execute those steps. And the first step, first instruction would be to pass the control to BIOS. All right. So BIOS, what it does, BIOS means basic input output system. So BIOS, what it does is it will perform a post operation. Post means power on self test. That means it will be sending a signal to all the devices, okay, to check whether they are responding or not. Okay, so whenever you shut down your system, right, so this list will be maintained. So what are all the devices which are connected? So when you start your system, so during the BIOS stage, it will check whether all those devices are uh, responding or not, whether they are connected, everything is fine or not. So it does that check, and then it will, what it does is it will try to identify the bootloader. Okay, so there are two stages of the bootloader. Okay, so it will so the first stage, it is called as MBR. It will identify the bootloader and it will pass the control to the CPU again, to the processor. Okay, now processor, what it does is it will load the MBR. So basically, MBR is of 512 bytes of size, and out of this 512, 446 bytes is of bootloader code. Okay, so which is related to the second stage of the bootloader, and it has some 64 bytes of partition table. So I'll explain more. 64 bytes of partition table, which can accommodate a maximum of 4 partitions. Okay, and then 2 bytes of a magic number, which is necessary during the boot stage. So now what happens is it will try to execute the bootloader code, which is there, the program code, and then it will, by executing the code, it will be able to identify the second stage of the bootloader process. Okay, so that is called as grub. So now the control will be pass it to the grub. So I'll show you the grub stage. So when you are starting your Linux operating system, you would uh, you would see a page, okay, where you would see all the options. That page will remain for a few seconds, and then it will start the operating system. Okay, so grub basically, in case if you have uh, multiple operating systems present. Okay, so at the grub page, the system will pause, asking the user to choose which operating system he wants to start. Otherwise, it will start the default one. So that is the stage that we have reached now. Okay, so here what happens is we will be so once the user chooses the operating system, it will be loaded into the RAM, and then the control will be passed to the next stage. Okay, so where there is we call it as the grandparent of all the processes, that is called as an init process. Okay, so the control will be passed to the init process, which is the first process that gets created in the system, and again init in turn will, it will start all the other sub processes, and login process is one among them. Okay, so then the login process will run, and it will ask the system to log into it. Okay, now here in this among all this list, so as I mentioned uh, regarding the init process, right? So there actually we have something called run level in Linux. Okay, that means if you start your system in a graphical mode, so it is one run level. You can also start your system in a non-graphical mode, so that is called as another run level. Like that, we have a single user mode, we have networking mode. Like that, we have different run levels. Okay, I'll explain more about these run levels. So basically, as a part of the init process, it will also choose the corresponding run level. So again, repeating all one after the another, how the system booting happens is it will first give the control to CPU, and then the control will be pass it to BIOS. All right, basic input output system. The post operation will happen, and then it will identify the master boot record. Okay, as a part of MBR, it contains the bootloader code that gets executed, and it will identify the second stage, which is the grub stage. Okay, and from the grub stage, the kernel will be loaded into the memory, and then the control will be passed to the init process. Init will identify the run level that has been set, and it will also start all the other sub processes, and login processes one among them. Now the user will be asked to log into the system at the login prompt. Okay, so this is a quick overview of how your Linux boot process works. Okay, if you have any questions on this, let me know. So now I'm going to quickly start one of my instance, and I'll show you the grub page. Okay, then you'll have an understanding of the grub screen. Just give me a minute, and meanwhile you can ask me if you have any questions. I'm just trying to start my instance. Okay, all right everyone, so I have a CentOS 6 version as well as a CentOS 7 version with me. Okay, just for uh, the grub page, I will be using CentOS 6 to quickly start it. So as you can see on my screen, I'm using Oracle VM VirtualBox Manager. You can download this software, and so inside the Oracle VirtualBox, you can have multiple operating systems installed. So you can see that. So this is how, so that if you have the base operating system as Windows, you can have VMware software and then have Linux operating system inside. Okay. Let's see. So here I have started one instance. Okay. So as you can see on my screen, so the system is starting, and I came to this grub screen, grub page. Okay. This is for CentOS 6. Similarly, you would have one for CentOS 7 also. Okay. Both are the same. So if you have multiple operating systems, so it will display those operating systems here. So here in this case, there is only one. So you can choose the operating system. So that is what the manual input that you have to give. So from here, so as I've said, once you choose the operating system, I'm pressing E, and here it's called as kernel. Okay, that is the location of kernel. So once you choose the operating system, then the kernel, the corresponding kernel will be loaded into the RAM, and then the initialization process and all the other things will happen. Okay, so these are all these three are part of the your operating system. Press E to edit, and the second line, so kernel is so the file name, the file the file or the package that contains the kernel, so it is named as vm linus hyphen version number. That's how it would be. Okay, all right. Now we'll go back to the slide. So if you have questions about the VirtualBox Manager, let me know. I will show you anyhow. I'll show you how to perform the installation part. Okay, there are different virtualization softwares. You can choose any of your choice. Okay. All right, we'll quickly move on to the next topic, that is our kernel. So I have only introduced kernel as the heart of the operating system, and then I talked about the utilities, the functions of shell, the role played by the shell and other applications and all, right? So why do we say that the kernel is the heart of the operating system? Okay, so basically it provides an interface between the applications and you can consider it as an interface between your hardware and the software, as well as you know the user also tries to interact with all the hardware, underlying hardware, using the kernel. Okay, you can take it in both the ways. Okay, so kernel, if you categorize, so all the things are taken care under the control of kernel. Okay, so there are some categories which I have mentioned. As you can see, the functions of kernel, the first one is it is responsible for managing the processor. It also takes care of managing the devices, right? So kernel basically contains modules. Okay, modules of software, and each among these modules, uh, your device drivers are also present. Okay, so every device that you have connected to the system, uh, so using the device driver, we interact with that particular device. Okay, so the kernel maintains all those device drivers, so they're present in the form of modules inside the kernel. So kernel basically maintains all these devices. Okay, and then we have disk management, memory management. Okay, so how these are managed, how the space is, how much free space is there, how files are being organized. Okay, so file system management, and then IO devices, all the inputs and outputs that are happening, all the requests that are coming and going out. So everything happens under the control of your kernel. And then we have system calls as well. So whenever you uh, uh, run a specific process or do some operation, there are a bunch of system calls that will happen in the background, and they will be executed under the supervision of the kernel itself. Okay, like this, all kernel basically takes care of all the things that are happening in your system. Okay, so that's why we call it as the heart of the operating system. Now the last slide, so where I'm going to talk once again about the grub. Okay, and then we will move to the installation process. All right, so grub basically, so it's called as a grand unified bootloader. Okay, so grub, we also have something called grub 2. So this is the latest version of grub. Okay, so uh, previously we were using grub, but now the grub 2 has come. So there are some minor differences between grub and grub 2. So I'll show you what those are once we uh, log in into the system. I will be showing you how grub looks. So I have CentOS 6 instance which is using grub. I have a CentOS 7 instance which is having grub2. All right. So I'll show the difference, like what are the files which are there in uh, grub and what files are associated in grub2. What are the differences that are there in the system, so that it will be easy for you to understand. So, but overall, remember the importance of the grub in general. So generally, like what is the role played by grub, so how it helps in loading the kernel, or where you choose the operating system. So this is the page from where the grub section which is there here, as you can see, right? So if you read the instructions below, we can edit the grub page, we can go to the kernel page, and from this screen, we can also give instructions to the kernel. So you can read at the bottom again, press E to edit. So this is how a kernel is executed. you can see, right, all the options which are there. So this is called as a grub prompt. Okay, from the grub prompt, the kernel, along with all the arguments which are there, it will get executed. So here, okay, so say for example you have forgot the root password. So root is called as the administrator of your system. Okay, it has all the admin privileges. The root user, say you forgot the root password. So again, if you want to reset the root password, you have to come to the grub page, do some changes to the arguments that are being passed to the kernel, and then that way you would land up in a troubleshooting mode or a single user mode where the system will allow you to change the root password. Okay, so we will see that that feature as well in today's session, but I want you to uh, get a feel of how these things are working. Ask me if you have any questions. All right. Okay, one second. Let me see. There is a question. Okay, so Rahul wants me to repeat this part once again. Okay, Rahul, sure. So here, so among all the stages that we have seen before, so I hope you remember the stages. We'll reach the grub stage. It could be grub or grub 2. Okay, so once we reach that stage, you will see this particular screen. Okay, just if you press escape, you'll just come to the initial section. Okay, so this is where you will see different operating systems. If you have multiple operating systems installed, okay, when you start your system, you would see all the operating systems here. Each operating system, if you take one CentOS S6, if you press edit, as a part of this operating system we have three options available. One is root, kernel, initrd. Okay, so it basically uh, says the order. So the root hd 0, then kernel, initrd is called as initial RAM disk, so that is useful as a part of the booting process. So I will explain that in some time. Okay, so if you take the second line, so that is the kernel line. So the kernel, there are a bunch of parameters which are passing to the kernel as arguments. So the importance of this page, the grub page, is so we can change the arguments that we are providing to the kernel, and we can start the system in different modes. Okay, when I say different mode, I mean if you want to troubleshoot, perform some troubleshooting, so you can pass the arguments to the kernel, start your system and do it. You can also reset or change your root password, or take a different scenario. Okay, so maybe you have mistakenly modified some core configuration files, because of which you are unable to start your system. Okay, so the only way how you will be troubleshooting this is, at the grub page, you modify the argument and try switching into the troubleshooting mode, and reset or revert the changes that you have done in the system, and then start your system in a normal mode. Okay, so that is another importance of here, another example for the grub page. Okay, I hope it's clear. Are you clear, Rahul? Do you have any other questions on this? Okay, yeah. So we have another question from Vijay. So regarding the other two options which are available here. Yes, Vijay. So for now, you can remember that initRD is an initial RAM disk, or you can also imagine that as a temporary file system. Okay. So before, so when I say file system, so it contains a bunch of files, okay, and some utilities. So before the actual operating system has to start, so what happens is, during the initialization stage, so initRD, it will create a temporary file system, and it will try to mount the partitions and start the actual operating system. So what I will do is, so since you are new to the Linux system, so let's move uh, uh, see how the actual file system looks like. Once you start working on the Linux system, you'll get a feel of how the operating system is. Then again we'll come back here. Okay, Then we'll again talk about initRD or the kernel. So then you will have a complete understanding of these topics. For now, just remember initRD is an initial RAM disk or a temporary file system which is used as a part of the initialization process. And second line is your kernel. The first line indicates where your operating system is and the order of the operating system. Okay, we'll come back again. So it's like we'll be doing back and forth so that I can introduce you to the topics, and once you're familiar with these topics, we'll come back again and we'll do a deep dive into each of these things. Okay. All right. So so another section is about the grub2. So mainly grub2 helps. Grub2 is the latest bootloader, so it is mainly introduced because it has a lot of additional features using which it supports all the devices, all the latest hardware and all. Okay, I will show you the exact files. How different are they? What is the difference between the grub and grub2 after logging into the system? All right, guys. So now we'll move to the installation part. Okay, so in your LMS, we have included the complete document that shows you how to perform the installation. Okay, I'll walk you through that document first, explain the steps that we are going to follow, and then we'll do a demo of the installation. Okay, perfect. So so as I've said, CentOS is a free operating system, right? So you can download it from the internet. In case if you have not done that before, let me show you the link from where you can download it. Okay, maybe you might also want to browse this site because you will get a feel of how things are in CentOS. Okay, okay. I hope you can see my screen now, right? So there is this site called mirrors.centos.org. Okay, so so there are a lot of mirrors available, or you can call them as repositories available as per according to the country from where uh, where you are located. Okay, so you can choose the mirror which is nearer to your place, and then so that way it helps you to quickly download the packages. Okay, so here if you observe, this is for CentOS 6. Similarly, you can browse the CentOS 7 packages. So all the packages are present here, and you also have images under this. What I'll do is, let me go back. Okay, so I click ISOS and then x86 underscore 64. All right, so here you can see all the mirrors. Choose any of the mirror for now, and here comes the CentOS 6.7 live CDI, so live DVD. Okay, now in this list you can see there is something called dvd1.iso, dvd2.iso. Okay, so it is sufficient if you download dvd1.iso. The ISO file is around 3.6 GB in size, so you can write it to a DVD, or you can use it as it is. I'll show you how to use it as it is. Okay, so this is from where you can download the operating system. And I've said kernel.org, you can also go there and see some of the features related to the kernel. Okay, perfect. Now we'll go back to the documentation. So once you have the media, which is your DVD or the ISO file with you, so we'll start the installation process now. We have also included all the links here. All the information is also present here. Okay, this process is simple. So once you have your ISO, or once you have your disk, insert your disk. Make sure that you choose disk as uh, your first boot device. Okay, so just remember the stages that we have followed as a part of the booting process. So if it doesn't identify uh, your bootloader, the second stage, all right, so that is how. So remember that steps that I've explained before and try to correlate this. So why we are changing the the boot device here, we are changing the order of the boot device here, because whenever the system is starting, so far it is trying to load the operating system from the disk, right? Now we want the system to read the files which are present in the DVD. So that helps in order to start your system. So that is one of the stage that we have seen over there. Okay, so by reading the DVD, so choose your media as the first boot device. So that is from where the OS will be loaded. So your installation starts. So if it is, so there are two different ways. You are directly installing the operating system in an instance, or you install the VMware manager, and inside the VMware you can perform the installation. Okay, and the prerequisites here. So if you want your the Linux operating system, if you want to start it in a graphical mode, I suggest that you at least have more than 1 GB of RAM. Okay, but even if you have 512 MB of RAM, you can start your Linux system. You can perform the installation and you can happily work on Linux system. But only for graphics, you would need a little bit more amount of RAM. Okay, so these are the prerequisites, and let's get started. So this is the first screen you would see when you have started your system by choosing your DVD as the first boot device. So it will ask you to perform. There are three options here. You can do troubleshooting and installing, the regular process, and we also have an option where you can check the media. So if your disk is corrupted, okay, you sometimes it, after doing half of the installation, it might throw an error to you. Some package got corrupted, some issues might come up. So it is possible to test the media in the beginning itself. Okay, so we'll go with the first step, which is installing CentOS 7. So the installation process is exactly the same for Red Hat as well as CentOS. You need not have to worry about that. So next slide. So it's pretty much, if you have done the Windows installation, it's almost similar to that. Some of the basic things like, so what is the type of language, the keyboard that you're choosing. Okay, so here you can see the date and time, the zone you're in, keyboard, the language support, and installation source, which is your CD-ROM. And then we have software selection. So under software selection, we have different uh, categories available. That means what kind of installation you want to perform, like what kind of setup you want to make. Is it for desktop, or is it specific, is it a server type configuration that you're doing? So where you would see all those options, so accordingly you can perform the installation. Okay, so even if you have not done the necessary package selection, post the installation we can do the installation of the packages. That shouldn't be a problem. Okay, for the beginners, you can choose the desktop specific installation. Okay, so here there are two important things. One is the installation destination. Okay, so in Windows we have C directory, and Macs, some people create D directory as well. Okay, but here uh, the file system structure is a little different. Okay, so first I will show you like how they look like. Okay, so and based on that I will explain the partition part. So there we call, in Windows we call them as drives, whereas in Linux we call them as partitions. Okay, so the partitions are represented as, for example, if you have a SATA disk, okay, so it is represented as SDA. Okay, so if when you create partitions on that disk, okay, it is SDA1, SDA2, SDA3. That is how they are uh, represented, identified by the Linux system. So I'm starting my instance. And meanwhile we'll just go through the slides, then I will show you once it gets started. Okay, so we need to create partitions here. So okay, first let's finish the software setup. So here I have chosen the Genome desktop. As you keep working on the Linux system, as you gain experience, okay, uh, you get to an understanding of what to choose, what type of packages to choose. You need not have to worry about the package selection. So there are a lot of options that are available. You can randomly choose and perform the installation. Okay, so then comes uh, the option about partitioning. Okay, there are two ways here. One is automatically configure partitioning, another one is a manual configuration. So I suggest that you do the manual configuration. I'll tell you the options, but if you choose the automatic configuration part, then you might have some problem in testing some of the features in the later stages. Okay, so proceed with the basic part, that is manual configuration. So in the manual configuration, you'll be choosing three partitions. In your system we'll be creating three partitions, so we call them as the standard partition. Okay, so you remember as a part of the booting process, I talked about MBR, master boot record, which is of 512 bytes in size. Out of the 512 bytes, I said 64 bytes is for the partition table. Okay, so each partition needs 16 bytes, so it can accommodate a maximum of 4 partitions. So 16 into 4. Okay, these are called as primary partitions. Alright, so in a system you can create a maximum of 4 primary partitions, or you create 3 primary partitions. The fourth one will be a secondary partition, inside which you create more logical partitions. So that is how the system is. So that is why we have an MBR. Uh, so it's like a restriction that we have. Okay, because of the limitations of the MBR, we can have a maximum of 4 primary partitions. So here the first one is the boot partition that we are creating. Okay, so all the what do you say, files which are associated with the booting process. Okay, we are going to keep all these files in a separate location, and we are naming it as boot. Okay, so in Windows we have everything under C drive. Similarly here what we are doing is we are just separating it, keeping it separately. Okay, so this is just a recommendation. So it's good if you follow it this way. It's not that we cannot do a similar installation like you do it in Windows. We can have just a single partition under which we finish the entire installation process. Okay, so for boot, it is recommended to create a separate boot partition, and you allocate if you're doing a RHEL 7 installation, so make sure that you have at least 200 to 300 MB of space allocated for boot. All the bootable files are present under boot directory. Okay, and choose the file system as ext4. In Windows you might have seen NTFS, right? Similarly in Linux there are a lot of file systems that are being supported, and ext4 is widely used. You can go ahead with the ext4 file system, which is the latest one. Okay, and so we have created a boot partition, and this is the size. You choose the file system here, And once the boot partition is done, the next one, again another primary partition, and that would be the root partition. So rest of the entire system will be present under the root partition, which is /. So in Windows we have /. Here everything is, all the folders are separated by a /, and the topmost folder uh, is called as /. Okay, so in Windows you have my computer, that is the topmost folder that you click, right? Under that you have C drive. Now here in Linux the topmost folder is called as root folder. Okay, and it is called, and it is represented as /. Under /, you have all the other directories. So we have created boot, you remember, /boot. So under /, we have boot directory as one of the subfolder. So that is the second partition that we are creating. So rest of all the files and folders in the system, they will come under the root folder. The third one is called as is the swap partition. Okay, so swap is a different type of partition that we are creating. Okay, so basically what is the importance of swap means, so I hope you all know that the importance of RAM, right? The operations that happen with respect to RAM are very fast in nature when compared to the operations that happen from the disk, okay, because of the disk seeks. So as you start working on different applications, or as you keep doing different operations, so all this content will get loaded into your RAM. Okay, it will be handled in your RAM, so the RAM keeps filling up. Okay, so in order to uh, make space, all right, so what RAM does is it will try to move some of the uh, unused pages from the RAM to a space called swap. As the RAM keeps getting filled up, alright, so it tries to create more space by moving the pages from RAM to the swap area. So that basically helps, and swap basically helps the RAM to create more space and keep functioning at a higher pace. So that is the advantage of having a swap. But as long as you have plenty of RAM available, the swap space will not be utilized. If you have plenty of RAM, and even if you're, say for example, you're using 8 GB or 16 GB of RAM, and at a higher load you are using a maximum of 8 GB and you still have 8 GB of free space, you don't need a swap partition. Okay, so we have included this because it is one of the question that you would get as a part of certification, like create a swap space, create a swap partition, and enable the swap partition. So that's how it is. Okay, cool. Now let's, so these are the three important partitions we suggest that you create by choosing the manual partitioning scheme. So you will not have these partitions if you choose automatic partitioning process. Okay, the system will create LVMs for you if you choose automatic partitioning, and if you create LVMs, the LVMs will take the entire space, and it will not allow you to create to do manual partitioning post installation. So we have manual partitioning in and third or fourth module where you will be manually creating the partitions. Other than the ones that we are creating during the installation, you will also be creating partitions at a later stage. But if you choose the automated way, so the system will take the entire space that is available and it will allocate to the root partition. So again, it will be a problem in the later part. Okay, so that is the reason why I asked you to choose the manual process. Okay, so once you have chosen uh, for a root as well as the boot partition, you will be choosing ext4, and for swap, the swap itself is the file system. So swap basically is a portion of your disk, but it will act like your RAM. Okay, so remember this, swap is a portion of the disk which will help RAM, or it will try to act as a RAM. So for that, the file system is swap itself, and it is recommended to have a swap size which is double the size of your RAM. If you're using 1 GB of RAM, then allocate 2 GB of space for the swap partition. So once that step is done, the system will, we have another option which is about network and host name. So it is possible to set up a host name in the installation stage, in this stage itself, and also you choose whether you want to have a manual IP address or you want to have a dynamic IP address. So usually if you're connected to an internet service provider, you get an IP address which is from the service provider, that is called as a dynamic IP address. Or if you want, you can manually set up an IP of your own. Say for example, you have a small private network. Okay, so what you do is you set up static IPs for your private network, and then again you connect to the outside world. So that way you have the option to choose here itself. You can either have a static IP or choose DHCP, which is one of the servers that we will see on how to configure. So using that, you will get an automatic IP address. So you can choose those options here. So there are a few slides regarding that as well. So if you don't choose the host name part, it will be called localhost dot local domain. But just remember, you need not have to configure everything as a part of the installation process. You can go with the default options, and even post the installation, you can perform these operations. I will show you all those examples for you. Okay, now moving on. So so the root password. So the root account which is there. So we use the word root to represent the topmost directory /, that is also called as a root, and root is also a user present in the system. Okay, so root user means he is the sole administrator for a Linux system. Okay, admin account with all the privileges. As a root user, you can perform any operation in the system. So the username is fixed. You just have to change the password. Here you set the root password, and then if you want, you can also create a non-root user uh, for your uh, system. So here you choose both the options, and your operation, the installation process will get started. So here, if you observe this message, creating ext4 on /dev/sda1. So it says ext4 is the type of file system which I asked you to choose, and so this is the path /dev/sda1. So under // there is a directory called dev, inside which there is a file called sda1. So sda represents your hard disk. Okay, so if it starts with S, it means it is a SATA hard disk. Okay, and you can also, if you're using IDE type, you might see HDA over there, or you can also see HDB. Okay, so /dev sda1 is the first partition. So it is formatting the partitions before starting the installation process. Okay, so sda1, so you have created three partitions. So sda1, sda2, and swap will be named as the swap partition only. Okay, so create your root password and another account, non-root user account, and then so once the installation is over, the system automatically gets started and it will ask you to accept the license agreement part. And once you have accepted that, so you'll have this kdump option, which is called as kernel dump, and means in case your kernel crashes, it will create a dump of log files, all the information. You can keep it automatic for now. That's it. So this is your login screen. So these are all the steps you will be following during the installation process. Okay, so what we'll do is we'll quickly see a demo of how this is done. Okay, So you can see here there is one instance. So I've just created the container. Okay. Now I'm going to start it. Perfect. So we have reached the first page. Okay. So I'm going to start with the install CentOS 7 option. Okay, we have a question from Priya regarding the Oracle VM. Yes, Priya. Once you perform the installation, I mean, it's just a software that you can download. You can search for it, even it's available at free of cost. Okay, so once you download in Windows, you can just double click and complete the installation process. Okay, so once it is installed, you would see a box like this. So this is open. You will not have these entries. So what you have to do is click on new, go to the next, then choose the operating system that you want to install. For example, uh, if you want to do CentOS, okay, so automatically the underlying operating system and version will get selected here, as you can see, and say I have named it as -11. Okay, just randomly. Next. So here you choose the amount of memory. So if you have enough memory in your system, go for 1 GB or 2 GB. Okay, so I'll just proceed with 512. Okay, then click next. Now we can see here you have to go with create new hard disk. So there are two options here. So there is this format called .vdi. You can see the file here, right? So it is like the readily available uh, software, CentOS operating system. You just have to load it, your system will get started, because everything is pre-configured for it. So you can either get that for practice, or go with create new hard disk option if you have an ISO or a disk. Okay, click on next. So we are going to create, so we are just going to create the container here, VDI. Next, or dynamic you can choose, or go with fixed one, and then this is your disk size. So choose at least 20 GB of hard disk will be allocated for this. Click next. Now you are done with the folder part. So this is your folder. Okay, you have created a container inside which you are going to install the operating system. Clear? So once you have created the container, click on select, next. So this is your ISO file. So the one that you have downloaded. So here you have to choose the media wherever it is. So once you choose that, click next, your system installation will get started. So that is the step that I followed. Is it clear, Priya? Do you have any questions? So this is a recording, so you can always go through the recording and perform the installation. That's the, okay. I have all the steps that I showed you. They are available as a recording. You can go through the steps and just download the software and perform the installation. Okay. Uh, all right. So where are we with the installation process here? So basically, the system has performed a few operations, and the installation process is getting started now. So the first screen where I have chosen to start the installation process. After that, some operation happened, so I have not done anything. Now the system is getting started in the graphical mode, where we will be seeing the first screen, which is about choosing the language. Okay, it seems my system is a little slow. Please bear with me. Or let me close the other instance. So here, when you're closing your virtual machine, you can always click on save the state. so that it will be easy for you to quickly start your instance again. Okay. So here, before this screen gets started, let me tell you an important thing. Okay. Sometimes uh, if you click in the center, so this is a virtual box, right? It's only for people who are installing on a virtual box. So if you click in the center of the screen, so basically the control is different for inside as well as outside part. So this we can control, but if you want to choose something inside, you have to click here, then the cursor goes inside. Okay, if you want to bring the cursor or get the control, just click on the control button which is in the right side. Okay, I repeat, so if you click in the center, the cursor goes inside. Just press the control button which is in the right side, the right side control, and the cursor comes out. Okay, perfect. So this is the first step, and I've chosen English and click to continue. Okay, so we got the screen. So here, date and time, English, keyboard, that's what we want. Okay, and then it is trying to read it, the installation source, that the ISO file which I've given, right? So it has read it. You have seen the change, right? And software selection, again I'll just proceed with minimum install. Okay, and then installation, this part will come here, and I choose, I will configure partitioning. Okay, once you're done, click on that. There you go. So this is the new screen that you'll see. Start with standard partition. Done. Oh, I'm sorry. Yeah. So when you click the standard partition done, you have the option here. See. So when creating the container, whatever space, disk space that you allocate, so that will be displayed here. So I suggest that you at least allocate 20 GB. Okay, so that it will be helpful for you to create new partitions in the later stage. So plus, I'm going to create slash boot, and the capacity I'll go for 300 MB. Okay, and choose the file system as ext4. Okay, then again plus forward slash. So here you can go through this, the drop down that contains different options available. Okay, you can create all those, allocate separate partitions to all those. So I will allocate for this, if you have 20 GB, allocate some 15 GB to it. For now I don't have that much, so I'll just say 5 GB. So entire file system will have 5 GB. My operating system will be installed on a 5 GB disk. Okay, again the file system I'll choose as ext4. Clear. Then plus, the next one is swap, and I've chosen 512 MB, right? So I'll give double 1024 and add mount point. And for the file system automatically got chosen, which is swap. So once you have chosen all the three partitions, click done. So now it is asking you to give a confirmation so that it will format all the partitions. on your disk. Okay, custom partitioning selected. Now go for network and hostname. So here I suggest that you follow some convention. Okay, like a fully qualified domain name that would be useful for you. Like I would say I'll give CentOS 7 dot cernvm.com. Okay, so the reason why I've mentioned this is this will be helpful for you to configure servers at a later stage. Okay, then so here you can see these are the options available. IPv4 settings are there. So this is automatic DHCP. If you want to create manual one, for example, okay, then you need to choose IP address. Say one of the uh, private IP address range is 192.168. Okay, so I have chosen 192.168.1.say 25. Okay, and for this range the net mask is 255.255.255.0. Okay, and then the gateway would be 192.168. I'm sorry, dot 1.255 2.1. Okay, and if you remember, in case if you have created a network, okay, we can have a common domain that is a part of the fully qualified domain that I've provided, right? So cernvm.com. So if I'm going to create multiple instances, create a small network, I'll use this as a common domain. Okay, and here the DNS server, you can just give the gateway IP address. So this is how we create a manual IP address, or you can simply choose automatic DHCP. Then you will get an IP address from the service provider. So if you're connected to internet, okay, perfect. Cancel, and I'm going to save these changes. Say done, and that's it. Begin the installation. Now I will change the root password. See, parallelly it has already started formatting the disk. /dev sda sd1. Okay, so choose the root password first. Done. Now I'm gonna create another user. Uh, so it's not always, I mean, since you're in the learning stage, you would definitely need the root account. You'll be performing all the operations as a root user, but it is always recommended to have a non-root user. All right, so you will be logging into the system as a non-root user, and whenever it is necessary, then you switch to a root account and perform the operations. So that is how things work in a real production environment. So it's not the root user account that is made available to everyone. Okay, so we create non-root accounts. We give some restricted privileges to those accounts. Okay, so unless it's absolutely necessary to perform something as a root user, people always log in as non-root users, and then they switch or they get some sudo access. There's something called sudo So when you get that access, you use that and perform a root operation. So it's like whenever you are, if you want to install something in the system, you need a root privilege. If you want to uh, create a user in the system, all right, or really anything related to administration, we need root access. So you switch and then you perform the operation, and then you become a non-root user. So that's how uh, things must be. That's how it is recommended to work in a Linux system. So as a root user, by mistake, if you delete a file, all right, related an important configuration file or something, it will be on the next reboot, your system might not start. So, or you can delete the entire file system by wrongly issuing a command. So that's why, so you need to be a little careful when you are running the commands. So in a Linux system, though there is a graphical interface, graphical uh, mode available, so mostly we will be working in a non-graphical environment, so where you would only see a command prompt. Okay, you'll be learning a lot of commands throughout this course. So every operation that you do will have a command, a lot of arguments will be there. It will be very interesting. So as you start picking up learning those commands, you would, believe me, you would definitely love the system, love working on a Linux system. Okay, so we'll go to the command line part. So you have seen so far the installation is going on. So once this is done, the system will get started, and it will ask you to accept the licensing, and the kdump feature, kdump page, if you remember, that's it, and it will get started again, and you're done with the installation part. Okay, so I'm closing this instance now. Any questions, guys? You have any questions regarding the installation? Okay, good. So like this, you can have multiple instances. You can create multiple instances here, and whenever you want, you can remove all those instances. It's as simple as it is. So as a part of learning this course, I recommend that you have two instances, sorry, two CentOS 7 instances, because when working on uh, topics like server configurations, you can keep one as a server, another one as a client, and test the connectivity and test the features, the server features and all. So you need two instances. So have two instances, try configuring private IP addresses, set up a small network between the two. So I will be helping you throughout the course. I'll give you suggestions. All right, if you have any queries in setting up a network, feel free, any kind of questions you can ask me. I'll provide as much details as I can. Okay, all right, so now we are done with the installation process. We will move on to the next topic. And so before moving on to the next topic, we'll take a quick break for 5 minutes, and then we will resume the session. And in the meanwhile, if you have any questions, feel free to post your questions in the question box. I'll be available and I will help you with your questions. Okay, so we'll resume the session in 5 minutes. All right, thank you guys. I have seen that everyone has given the confirmation. Let's get started now. So the next topic now, we're going to see uh, a lot of commands starting from this page. So you'd see me. We'll start with the very basic ones. Okay. So this is the screen now. I hope you all can see my screen, right? So you can only see a black screen with a shell prompt. So this is how your Linux system would look like if you are in a non-graphical mode. Okay, I will also switch to the graphical mode, but I've just started it. So here, so this prompt, what it says you is, if you closely observe, so it says root at the rate. That means so this person uh, is the user who has logged into the system. Okay, or maybe I will just exit and show you something else. So this is what you would see as this is your login screen in a non-graphical mode. Okay, and given username and password. So now I have logged into the system. So how I have logged in as a root user. So this is what it's displaying here. So root at CentOS 7 means, so there is a command called hostname. If you run hostname, you would see the entire uh, name of the name that has been set up. So it is partially displaying my host. It says that this user has logged in into this particular system. Okay, and there is a small tilde symbol here. So tilde symbol represents my home directory. Okay, so as a root user, I have logged into the system. When I have logged in, I will land up in my home directory, which is /root. Clear? And the hash symbol, which here it represents that the user is root. Okay, and for non-root users, you would see a $sign here. Okay, so you might ask me, like, it already shows the user as the root. Why do we need another representation? Okay, because so this part which is there, so we can modify it. We can tweak the fields here. So this is always fixed. We cannot change it. Okay, so that helps you to identify the root user. So we can change the inside part. We can make it short or just use the username or the host name. We can make those changes, but here using hash you can identify that it is the root user. Similarly, if you have a $sign over there, it is a non-root user. Clear? Okay, so I have mentioned that /. See, the way you click my computer, the topmost location in Windows. So I'm doing cd space /. So whenever I move to a location, so that path is displayed here. So now I came to /. That is the topmost part in my Linux system, and do something called ls. Ls means list the contents of this particular folder. I am under /, list the contents of this folder. So you can see here there are different names which represent the first level directories present in the system. Okay, so there is an importance to each of these folders. So they'll be more or less the same after you perform an installation. Okay, so each folder has a specific importance that you have to remember, because you will be interacting with all the folders and all the files which are present inside. Okay, so coming to the importance of each folder, /, as I've said, it is called as the root, the topmost folder in your Linux file system. And then we have /bin. So bin represents binaries. Okay, so binaries are like executable files. Okay, I'll give you an example in order to have a clear understanding of what this means. So now we have seen me running a command called ls, right? So when I give ls as an input, the system is showing me some output. So how is it interpreting this particular command? So ls is a command. So how is the system interpreting? So there is another command called where is. Okay, so I'm asking, so where is ls? So it says it is present somewhere under user bin ls. Okay, now I want to know what this file is. So there is a command called file user bin ls. Okay, it says that so this file is an executable file, which means so whenever I'm giving issuing ls command, so it in turn is executing this particular file. Okay, so which is an executable file. So we call them as binaries. Okay, so the binaries, so every command that you run in the system, for example cd, okay, so there will be an executable file corresponding to cd which is present under user bin cd. When you give cd, it in turn executes this particular file which is present under user bin. Okay, so this is how the system works. So that's why we call these files as binaries. So they are present in different folders. So if you go to /bin, there you can see these are all the binaries, different commands present. We may not be using all this, but so maybe one quick example. There is something, which one? Okay, so all these are the different binaries. If you take zcat, all right, if you have a zipped file present, you can display the contents of a zipped file using zcat. Okay, like that. Uh, all these are different binaries or different commands that we can make use of at some point. Okay, so these binaries are distributed in different folders. One is /bin, and you might also find them under user bin and the folder sbin. Okay, whenever you see a folder name that says bin, that means it contains some binaries. Binaries are system executables. So whenever you're running a command, there will be a corresponding file containing the code, so that gets executed, and that's how and you will see the end result, the corresponding end result. Okay, perfect. Next, important directory. So all these first level directories which are there, so they are grouped as per some features or some specific functionality. So these are all binaries at one location. Then we have another folder called as dev. So all the device related files are present under /dev. So if you observe here, so under /dev, we have seen uh, one second. Okay, so here you can see, right, SDA1 and SDA2. So under /dev we have SDA1, SDA2. So what are SDA1 and SDA2? These are the two partitions that we have created. So /dev is a directory that contains device related files. Now one important thing that you all have to remember here is a Linux system only contains files. Everything is a file. Okay, so that is how the system will consider. That means here SDA1 is your partition. So it says SDA. SDA is nothing but your hard disk. So the hard disk is represented by means of a file. There can be different types of files, but everything is a file. So all your hardware, so when you are interacting, when you are saving something to your hard disk, that means you are making use of this file. You are saving it to this particular file. Okay, so assume like that. So everything, so the only difference is we have types of files like a text file. Even directory is also a type of file. So here all the files that you see here, so cd-rom, so it is also represented as a file. So when you're interacting with the cd-rom, when you're trying to use a cd, so basically the system will uh, try to control it using this particular file. Okay, it will consider this file as a cd-rom. So everything is a file in a Linux system. All right, we have config files, we have text files, we have executable files, binaries, we have device files. Even processes are also identified. Every process will have corresponding file or a bunch of files. Okay, that keep getting generated in the system randomly. Whenever you create a process on the fly, there will be a bunch of files created that maintain all the information related to that process. like that everything is a file in a Linux system. Okay, so /dev contains all the device related files. Clear? Then now we'll go to the next topic, which is about etc. So sorry, uh, etc folder contains all the configuration files. Okay, so whenever you want to uh, remember the configuration option that we have seen, we configured the IP address, right? The static or the dynamic address part. So that let me show this file to you. So there is a file. So remember that everything is separated by a forward slash. Okay, you can assume an inverted tree structure which starts with forward slash. Okay, under forward slash one of the directories etc, and it's like a branch. Under etc again we have lot of subfolders and files present. Okay, etc sysconfig network hyphen scripts. So this is a file. Okay, I'm opening this file. So here if you see, right, so remember the static IP address configuration I have done during the installation process. So that again it comes in a file. All right, I keep repeating, everything is a file. All the changes that you make, if you want to excuse me, if you want to configure a network device, or if you want to run some service, there will be all the configuration information will be present part of a file. So the process before running, it will read all that information and it will run accordingly. Okay, even here your network service, so whatever changes we made there, everything is part of this. If you want to again uh, uh, want to get a IP address dynamically, you again make changes inside this file. So it's all about handling the files. Okay, so those are the areas where we will focus a lot in the initial phase. So we'll be uh, as I keep talking about these topics, I'll be running some of the basic commands. I'll tell you what the commands are, and then we'll see how to create, how to modify, how to edit the files, etc. Okay, then the next so /etc folder contains all the configuration files. Any service, new service that you install, any software you install, the corresponding configuration file will go to etc. Clear? Any service. So like that, if you install one service, the corresponding configuration file goes to etc. As a part of the software, if there are any binaries present, okay, those binaries will go to /bin or sbin folder. Okay, and like that, if you take one software package, it can have many components. Like it can have binaries, it can have configuration files, it can have man pages, right? So all these parts which are there, each part goes to one particular branch, like etc one part, /bin one part. There is another folder called as /lib that contains all the library files. So those library files will go to that location. So all the packages which we have selected during the installation part. So what happened during the installation? So every package has been distributed into this tree structure. Okay, so that is how it has been set. And then we have another important folder called as /home. So /home folder contains uh, all the user information. So two things here. A root user is a most privileged user, so he only enjoys a separate home directory, which is /root. Okay, all non-root user accounts, so they'll have their home directories present under /home. If you go to /home, if you create a non-root user, new user, he'll get a home that is allocated under /home directory. Okay, but if you want, you can also make changes. So whatever I'm talking, just I'm introducing these topics, but we'll go to the advanced level in the other modules where we'll see different locations. when creating a user, we create a home directory at some other location, or there is already a home directory present, we modify it. So all these changes can be done. We'll deal with those changes in the later stage. Okay. Then moving on, we have a lot of such folders. Okay, so slash root, I said the home directory of the root user. Slash proc, it contains all the process related information. So there are a lot of processes running in the system. You can use the command called, see, these are all the processes, or there is a command called top. If you run it, you can see all the processes that are running in your system. Okay, now okay, now moving on, we have another folder called OPT that contains, I mean, in case if you have installed some third-party packages, so usually they'll be installed under slash OPT. Okay, and then MISC is used for automatically mounting the directories. Now again, a new word has come. So what is mounting? What is the process of mounting? Okay, so now take the Windows system. Okay, now you have inserted a USB disk. Okay, so when you insert it, what happens? Automatically the system identifies it uh, with a drive name called as F or G, and there will be a new window that is opened that contains all the contents of the USB disk. Correct? So the process of uh, connecting the USB disk to the system and allocating a separate folder name is called as mounting if you do it manually. So window automatically identifies it and it creates a new page, a pop-up window that contains the contents of that USB disk, right? In Linux, so we do it manually. So what we do is we manually say that mount, and so this is the drive, and so the USB drive will be identified in the system. So we have slash dev SDA1 as the first partition, SDA2 as the second partition. Similarly, when you connect a USB drive, so there will be a file that gets created that represents the USB drive. Take it for example, slash dev SDB is that file. Okay, you can check that. So once it is created, what you do is use the command called mount and mount this particular drive to a particular location. So there you give G or H that gets automatically allocated. Here we choose a particular folder, say for example slash temp, and we mount it. Then what happens? All the content which is present inside the USB drive will be displayed under the slash temp folder. Wherever you mount it, in that place the content will be opened. Okay, so that is called mounting process. We'll see more of the mounting uh, process in the later module. Okay, then so slash media, I mean, in case if you use any CD or DVD, so that content will be identified and is opened under slash media location. Okay, so moving on, we have sbin, which also contains some binaries, and slash temp is a folder which is uh, it's temporary directory. Okay, so all the users, so basically in Linux system, as I said, root user, non-root users, right? If you're logged in as a non-root user, you'll not be able to see the contents of other users home directories. Clear? Let me give you an example. So I am a root user. Who am I? I'll switch to a user called Saran. Okay, and pwd, present working directory, I'm under home. So cd means change the directory. So I went to my home directory. Say for example, if I want to see the contents of a different user in the system, Okay, so I'm user Saran now, and I'm trying to enter into the home directory of user 1. Permission denied. So non-root users, they live in a restricted environment. They cannot enter other people's home directories. They cannot make changes to the configuration files. Maybe I'll give you another example. I'm opening one configuration file. Okay, and I'm so forget about the command that I'm issuing. I only want you to observe that I'm trying to make some change, and the system is throwing a warning stating that I'm trying to change a read-only file. That means, as a non-root user, I am not allowed to make any changes. I only have read-only access. I can read the contents of the file, but I cannot make any changes to it. Okay, so that is how uh, the system, it restricts the non-root users. But slash temp is the only folder in the system, okay, which is like a shared folder. So any user can go to slash temp and keep his files uh, for a temporary period of time. Okay, so that is what the slash temp is. Perfect. So now introduction to shell or the bash shell. So if you remember the architecture diagram, around your kernel, you will have another layer that is called as shell. So it is only because of the shell that we are able to interact with the system. So we are issuing commands, and it is interpreting those commands and passing it to the kernel and getting things done. Okay. So there are different types of shells present in a Linux system, and by default, we are using bash shell. Okay, so that information you can get it in one of the configuration file, so which is etc shells. So here you can see, so these are all different types of shells that a Linux system supports. So when I see shell, a shell is like a software with a bunch of features. Okay, so we'll be using bash shell. If you want to see, uh, so it says slash bin slash bash. So by default, we have landed up in a bash shell. So this is the shell that we are using, bash. Okay, so we would be mostly we'll be doing everything, all the operations, learning everything using the bash shell only. So there are other shells that are available. So some of the system processes, they make use of the no login shell. So no login shell is something, for example, some softwares, they need a dedicated user to run that software, like Oracle. Okay, it creates a user called Oracle, but the user is not, you cannot use that username to log in into the system. Okay, that is called as a no login shell. You cannot log in into the system as that user. It can only be used in order to run the process in the background. So that is called as no login shell. Like that, we have other shells. I will provide more details in a later part. For now, just remember that we'll be using a bash shell. So there are a lot of features for the bash shell. So the reason why we are using bash shell. So uh, one second. Perfect. So let me show you what are all the features why we are using bash. Okay, so I have used a lot of commands in the past 30 minutes, right? If I want to see what those commands are, I can use the upward or downward arrow. So by pressing upward arrow, it will show me all the commands that I have used previously. Okay, so this is a feature of the bash shell. One. Now the second feature, say for example, I am typing a command ls. all it's case sensitive, so it should be in small letters. Okay, ls space forward slash, and I'm not sure uh, what I have to give as an argument. So what I can do is I can press the tab twice. So ls space forward slash, press tab twice, then it will help me by displaying all the information which is present under forward slash. Okay, I've seen all these folders. Okay, now I will choose um, user. Okay, and I'm not sure about what to give next. Then press tab again, so it will tell me what is there inside user. User src, again tab twice, kernels. Okay, so like that, if you press tab twice, it will display, it will help you by providing all the information. Clear? Now again, so the third one, now the third part is command line completion. That means say for example ls forward slash, I press u, it has completed the sentence. Okay, usr, I only pressed u, press tab, it will complete. sh, press tab, it will complete the remaining word for you. Okay, in tab info. So the tab is something which is which would really help you in in making your uh, uh, the execution time will be very less. You'll be working at a higher pace as you get used to this tab. So it will help you to display. It will give you suggestions. It will help you to complete the command. And let's take another example. So if you press Control R, you'll get a new prompt over there. So that helps you to search the commands that you have used previously. So I pressed Control R, and I will give one or two letters which I am aware of the command that I used previously. See, I have just given if and it has retrieved. So it's gonna save a lot of time. I need not have to again type vi space forward slash etc sysconfig. It's not needed. Just Control R, two letters. It will bring that for you. So this is called as a reverse search. Okay, by pressing escape, so it will set it for you for execution. Clear? Now, like that, there are a lot of features of the bash shell. So if you look at the screen here in the slide, so there are other shortcuts present. For example, if you want to go to the beginning of the line, Control A, so the cursor quickly moves to the beginning. Control E comes to the end. Okay, Control R, reverse search. Like that, there are a lot of shortcuts that would really help you to you know make your life easy when you're working with the Linux system. So if you parallelly remember the shortcuts as well, you will not uh, you know you really enjoy working with the system. It would helps you, in a very shorter time you can learn a lot of things by quickly making use of all these features. Okay, so this is pretty much about the bash shell. Now we will move to the next topic, the prompt. So this is something which I have already explained you before, right? So the username at localhost. So remember the slide where if you don't make uh, if you don't update the hostname part, it says localhost dot local domain. So here you will see that name here. So user at this system, the tilde symbol always represents your home directory. So any user, if you use the tilde symbol, let me give you an example. Okay, so I am moving to a different location. I said cd, change directory. Okay, change directory to temp, pwd, present working directory is temp. Okay, now if I say change directory tilde, it will take me to my home directory. So it's a short form. So tilde represents your home directory. Okay, and the dollar says that you're a non-root user. Now the next one is about switching. So if I'm, who am I? Okay, I'm a root user. So if I want to switch, I say su space. That means in Windows you basically click logout and then you log in as a different user. But here, just the moment you blink, I'll switch to the other account. So that's how it is. So we can do everything from the shell front. So su space user one. Who am I? User one. So a root user can switch and become any user in the system, but it is not the same with non-root users. Okay, so now I'm a non-root user. Okay, who am I? User one. If I want to switch, su space surrender, the system will ask me for the password, assuming that only the privilege, if uh, it is, the system assumes that only people who have been authorized should switch. Okay, so if I know the password, then the system considers that I'm authorized, but it is not the case with root. So root is the admin and he can perform anything, he can do anything. So exit to come out. Okay, so that is what su command is. Su means switch user. There is a small difference, I'll tell you, which is let me go to the temp directory. Okay, who am I? Root. Now I'm switching to a user called Saran. Okay, pwd/temp. So when I use su command and when I'm switching, the folder doesn't change. So I remain in the same directory and become the new user. Okay, now I'm using hyphen before switching. So when I use hyphen, I would land up in the home directory as that particular user. So that's the difference between su and su hyphen. Okay, switch as the user and land up in the home directory. So depending upon the use case, depending upon your need, you either use su or use su hyphen. Clear? And we have few more basic commands to learn. Among them are the one I mentioned, hostname, and then we have another command called hostname -i. If you have declared or mentioned your IP address inside etc hosts file, then you would get the IP address in this way. So there is a file called etc hosts. So in this file, if you have mentioned your host name and the corresponding IP address, okay, if that mapping is present, then after you run hostname -i, it will fetch that IP address and display it for you. Okay, what is the IP address of this host? Otherwise, you can use ifconfig. In Windows, it is ipconfig. Here you use ifconfig. So ifconfig. So this is my Ethernet interface. Okay, so every system will have an Ethernet card. So that basically allows us to communicate with other systems in the network, right? So here you might see the Ethernet card identified as ETH0, ETH1, or in CentOS 7 it is usually it would be ENP0S3. Okay, so here you can see this is my IP address, the subnet mask, the broadcast address, and all those details. So this is how you can check your IP address. Perfect. Now we will see a few more commands. So far I hope it's clear that um, how the file system looks like, starting from forward slash, and inside that we have a lot of directories. Okay, just assume the Windows My Computer, CD, again C drive, there are other folders. Okay, now when you want to switch between the folders, so CD is the command that you use. So here you need to provide the exact location, so where you want to go. So even in Windows, if you are not aware of a particular folder, right, so you use what we do, we click on My Computer, then program files, then go inside, right? Or if you, even if you know the name of the folder, you can't just give the name and open the directory. You need to provide the entire URL, I mean entire path of the folder. So even Linux works the same way. CD forward slash etc sysconfig network hyphen scripts, and then press tab or go there. Clear? So this is how. So you need to, if you want to switch from one location to another location, so the more you keep working on Linux system, you'll get used to the names of the folders and all, and it will be very simple for you, easy for you to switch between the folders. So there are even some shortcuts with respect to the folders. So pwd. So if I use cd space dot dot, I'll go uh, one level up in the tree structure. Okay, so cd space dot dot, I go to etc, cd space dot dot, I go to forward slash. So dot dot, if you want to, so you need not have to type the entire path again, just press cd space dot dot, go one level back. Okay, now let's again go to etc sysconfig network hyphen scripts. Okay, and from here I go to slash temp. Okay, now if I want to go back to network hyphen scripts, I can directly say cd space hyphen. It's a shortcut to move from temp to network scripts directly. So it's almost like if you have a remote, so there is a special button in the remote that will take you to the previous channel. Similarly, cd space hyphen will take you directly to the uh, previous folder where you were working. Okay, so like that. So these three are the shortcuts that you can make use of when moving from one folder to other folder. So the folder is the word that we use in Windows, and then next we call them as directories. Okay, directories and files. Now I came back, pwd, I came back to my home directory. So cd, if you just press cd without any arguments, you will always land up in your home directory. Okay, now ls, there is nothing in my home directory, so I want to create some files. Okay, so touch file 1. So touch is the command that creates empty files, the blank file. Okay, so cat is the command that is used to display the contents of a file. So cat file 1, there is nothing inside, I have created an empty file. Now say I want to add something to this file. So there are different ways. So first I'll show you how to add content on the command prompt itself. Then I'll introduce the concept of VI editors. So editor is a software using which you open a file, make changes to it, and save the file and close it. So that is how VI editor works. So you have a file in Windows, right? When you double click on, say, take one text file, when you double click on it, it gets opened, right? So similarly here, when you pass a file to a VA editor, it will automatically open it in an editable mode. So you make changes to it and then you close it. All right, just try to correlate both. So that will go there. So before that, say if I want to make changes on the command prompt itself. So here what I'm doing is cat a single redirection operator, and I say file1. So add some content. Cat, a single redirection means I want to add something to this file called file1. So now it will allow me. So I'm adding content to this new file. Okay, and to get the prompt back, I pressed Ctrl D. Now upward arrow, cat file1, you have everything. I pressed Ctrl D, D for devil, to get the prompt back. So I'm able to add content to this particular file. Okay, let us do this operation once again. New content, Ctrl D, cat file1. So now if you observe the previous changes, the first time when we have made the changes, those files are missing in. So a single redirection operator, every time you use it, what it does is it is going to overwrite the contents which are previously created. Okay, so it is not appending the contents. So what we have to do is, if you want to append, you need to use double redirection. Append me now. Okay, so you can just ignore this part. You have a new mail, so there is some issue that's popping up once in a while. So if you observe here, so it has appended the content. So this is how we can quickly add some content to a particular file. Okay, so we have created a blank file. We have seen how to display the contents of a file, and then how to append something to a file. Clear? Now similarly, if you want to create a directory, so I've used ls command. So now I'll use an argument to ls. So there is something called ls space -l. Every command in Linux can have a lot of arguments. Okay, that means uh, arguments basically help you to generate more information. Okay, so ls just displays the contents of a particular folder. So if you want to know more information about that content, you need to give additional arguments. Okay, like ls-l. So what it is doing, it is displaying the file along with the permissions, and so these are all the permissions associated with that file, who is the owner of the file, and what is the group to which this file belongs to, what is the timestamp associated with that file, like that. So it's a long listing of that information. Okay, so we have done cd space hyphen. Hyphen is also an argument that we have provided. Okay, all right, now I'm going to create a directory. So mkdir dir1. So the reason I introduced ls-l is, now you can see the difference. So along with the permissions, there is this first field that says whether it is a file or a directory. So hyphen represents that this is a file. If it is a directory, it says D. Okay. So mkdir dir1, I have created a directory. So pwd, now cd dir1. So I have moved to the directory, moved inside a directory. Again, if you want, it's as simple as it, mkdir dir2. Okay, cd space dot dot, I came one step back, so there is one directory. So if you want to delete an empty directory, then you can use the command rmdir. Okay, let me just exit. Yeah, so again I'll use mkdir dir1, go inside dir1. I'll create two directories now. So we can create multiple directories by passing the names as an argument. Okay. Now let us create a file inside dir2. Okay. I say file2. So dir3 is empty. dir2 has some content. So as I said, rmdir command will help you to remove empty directory. It says directory not empty. So for that we have to use rm command. Rm space hyphen r. R means recursively. That means include everything which is inside. See, it is asking me for confirmation. If you give hyphen r f means forcefully, then it will not ask you to give confirmation. It will directly delete the moment you issue the command. Okay, so this is how we delete the directories. The same rm command is used to delete the files also. Okay, touch file 1, rm file 1. Yes, clear. So this is, so we have, so far we have covered how to create the files, how to add content to the file, how to create directories, how to delete the directories, how to delete empty directories, how to delete directories which has some content inside, and then we have seen some cd commands as well. Now we'll go to the next section on copy and renaming of files. Okay, so there is nothing inside. I'm creating an empty file. Okay, and I'm creating a directory called dir. Now cp is a command used to copy the files, so I'm copying this file. See, always remember the way we give the instructions, right? So what I want to do, I want to copy, so I'm using cp command. So copy what? Copy the file called file1. Copy where? I want to copy it to a location called dir. So this must be clear. Okay, so copy file1 to dir. So if you have a different location where you want to copy it to, you provide the exact path of the location. Okay, just don't randomly give the name. So what you want to copy, give the proper path. Since this file is present in the current folder, we need not have to give the path of it. But if it is present in a different folder, then we need to give the folder path, file name, and then what is the destination where you want to copy it. Okay, and the destination, if it is a directory which is present in the same folder, then just give the directory name, else give the total path of the directory. So copy file1 to dir, or similarly copy /temp some xyz, for example file. I want to copy this to another location, etc sysconfig. So here if you observe, if it is a different location, if the file is present somewhere else, then you have to give the total path. So this file present in this location, copy it to this particular location. Okay, so that's how it works. So copying part, so you have seen how to copy files. Now we'll see how to copy a directory. So create another directory and copy dir name. So, okay, let's take another location. So copying a file, this is what we have used for copying a file. For directory we use -r additionally. So remember the remove command. So if we use remove command on a directory that has content, it will not allow us, because we need to add -r argument, because it has to recursively, one after another, it has to delete everything. The same logic applies here also. When you are copying a directory that contains some content, you apply -r. So recursively, so everything directory along with its contents must be copied. Now ls temp, you have the dir. You can see that, right? So that's how you have to copy as well. So you can use the similar format. uh, so copying part is done. Let's see how to move the files. So copy the same thing that we do in Windows. So moving the file means cut and paste. Okay, so we have command called move. So move, again the same. What I want to do, I want to move what, file 1 to where, dir. So since this file is already present inside dir, it is asking me whether it has to overwrite. I say no, rather I will move it to dir new. Okay, ls. So the file is not there, so it has been moved to dir1. So this is how we move the files. Okay, and the same command is also useful in order to rename the files. Say touch xyz. Okay, so move xyz to abc ls. So move command is also used in order to rename the files. So these are the basic ones: copy, delete, remove, move. Okay, the ls command, cd command, how to switch between the files. And then you have a cat command. So we have used cat, how to display the content, how to add the content to a file. You can use the cat command in multiple ways. I mean, say for example, we'll take the same one. So cat redirection abc, this is what we did, right? So I'm adding x something inside, control d. Now I'll take another file. So even if the file is not present, you can pass it as an argument and create it. So I'm directly passing xyz, some random file name, as an argument to cat. So it will create it and add content inside. Okay, and you can use cat command to display the contents, right? And we can display the contents of multiple files at a time. You just have to pass them as an argument. So the way you created multiple directories, touch f1, f2, f3, so it will create 3 files. The touch will create all the 3 at a time. Similarly, you can create mkdir, d1, d2, d3. It will create 3 directories at a time. Similarly, you can delete multiple files at a time. You can copy multiple files at a time. Okay, so all these commands, you can display multiple files at a time. So they are equally applicable for one or more files. Okay, so we have covered this. Then we'll go through some more basic commands that are available. So the one important one that we have seen so far is ls command, right? So ls, it displays the contents. ls hyphen l will give a long listing. So we have the concept of man pages. That means files that contains information about the commands. Okay, so man pages means manual pages, manuals. So if you type man space ls, so then it will display the manual corresponding to ls command. Okay, so you can read what ls is for, what are the arguments that are present for ls. So you can use all these arguments. Each argument gives a different I mean, each argument gives new information about the content that you are displaying using ls. Okay, so you can go through this, because we're not going to use all these arguments, but there are some important ones that would be helpful for you. So whenever I use it, I make sure that I point it out so that it will be easy. Otherwise, feel free to ask me a question on that. Okay, I'll quickly just to make you understand this, I'll quickly use some of the arguments. So ls hyphen l we have used, right? It's a long listing, and there is an ls hyphen a. So what a means? So a is used to display all the files and folders. Now what do you mean by all? So if you create a file that whose name starts with a dot, okay, so I name it as file 11, and I create another one, and if I do ls, you will not see file 11 and 12 here, because these are called as hidden files. So hidden files, if you create a file name with a dot, it will be hidden. So using ls command, you cannot see that. So you need to use ls-a in order to see that. Similarly, you can hide the directories also. Clear? So that additional information can be obtained using -a. So we can also combine both -la. So give a long listing of all the files along with hidden files. Okay, so like that you can add lot of arguments that you want. ls-lar, it will change printed reverse order. Okay, like that there are a lot of arguments that are associated with ls command. So every command will have all these arguments present. So you can see for example man rm. So all the man pages have the information of what the command is, what is the use, what are all the different arguments that you can pass to that command. Okay, so we can achieve a lot of things using all these arguments. So these are all the commands that we have seen. So the new one is echo command. So as the name says, okay, so what is echo? So whatever you give, so it just give it back to us. Echo space 1, echo some word. Okay, so we can make use of uh, this feature to create content inside the file. So rather than giving it back on the screen, I want to save it inside a file called file1. So now cat file1. So that the content, rather than throwing it on the screen, you save it inside this particular file. Okay, so echo 1234 redirect file1. So now cat file1. So if you remember, single redirection is always overwrite, double redirection means append. Okay, so this is how the echo command will be used. So we have used echo command for a different use case as well. If you remember, echo dollar shell. So this dollar shell is one of the system variable. Okay, there are a lot of system variables present. So I'll give you the list how to retrieve them. If you want to retrieve the system variables, how do you retrieve a variable? So using the dollar symbol. So we use echo dollar to get the system variable. For example, echo dollar home. So this is another example. So my home directory is stored inside that variable. Okay, so we'll see more of these variables in a different section. So moving on, so I have talked about man pages. So we have seen how to display multiple files using a cat command, how to remove files, how to remove the directories as well, right? How to create how to create directories using mkdir. R command is recursively list the contents of a directory. So we have seen that option as well. And then we also have some more commands like more, less, head, tail. So we'll take one example like, so if I do man ls, you know what happens, right? So it will display the man page. So rather than displaying that on the screen, I'm redirecting that to a file called file1. Okay, I hope you're getting how to use this redirection operators, right? So if I want to open, I can say cat file1. So cat, what it does, it will just uh, open that file. So whatever content which is there inside that file, it will throw it on the screen. So that's what cat does. But I want to read this file. So this is not an efficient way of opening the file for reading, right? So I use a different command called as more file1. So cat, what it does, so irrespective of the size of the file, whatever is there inside, it will just throw it on the screen. But what more does is it will open one screen of information at a time. So you can see here, right? It has opened it. Still it didn't quit. So if you press enter, it slowly displays rest of the content. So you can slowly go through the content, read through it. So this is what a more command does. Similarly, we have less command and head command. So head displays, so head rather gives the prompt back. Okay, so head will by default display some 10 lines, I guess. So it prints 10 lines on the screen. We can also ask head to be specific. I only want 5 lines, so it will only print the top 5 lines. Okay, similarly tail, head will print by reading a file from the top to bottom, and tail is like it will read from bottom to top. Okay, so that is how you can make use of head as well as tail commands. So the ending of the file will have these 5 lines. So based on the use case, you'll be making use of all these commands. Okay, so we have seen move command, how to apply it on files, how to move them, how to rename them, and we have also used copy command so far. So then comes text editors. Okay, so VA editor uh, is widely used, or so one of the widely used text editor. So there are different types of text editors. When I say different types of editors, what I mean is editor which are used in non-graphical mode, editors which are used in graphical mode. So graphical mode is more or less same like the Windows one. Okay, so non-graphical mode, we'll see how to use them in the non-graphical mode. Now, so VI, or you can also use VAM if available. So VA editor, visual editor. Okay, VAM is the latest modified visual editor. Okay, and if you give the file as an input, it opens the file in a VA editor. So here you can make changes to this file. So initially it opens the file in a command mode. You need to press I to enter the insert mode. Now you can delete the content, you can add new content. You need to press escape again to go to the command mode, colon WQ, save and quit. W is to save, Q is to quit. So that's how you open a VA editor. So this is the command mode. So what is command mode? Say if I want to search something, /list, enter. So it is displaying the matches. So you can give commands. But if you want to edit, press I. Where is your cursor? Type anything. Press escape. Save. Only saved. Q. Now quit. Give me the prompt. Okay. Like that, we have a lot of options present as a part of the VA editor. Even VA editor has a lot of shortcuts. Where are you now? So the cursor will save. So if I want to quickly go to the end of the file, so you don't want to press the downward arrow continuously till it goes down, right? So shift G will take you directly to the down. Okay, similarly, if you want to go to a specific line, colon, I want to go to line number 100, so it will take you to line number 100. Okay, so there are a lot of shortcuts in the VA editor as well. So when you want to delete, when you want to copy paste, okay, and you want to delete words, if you want to delete the entire line, if you want to go to the beginning, if you want to create a new empty line. Okay, where do you want to create? So above the position of cursor or below the position of cursor, like that. So with VA editor, again, there are a lot of shortcuts available. So as in when needed, I keep telling you the shortcuts that you can slowly practice. So don't worry, I can perfectly understand. This is like, so if you're not aware, if you're new to Linux system, this is too much of information for you. So I'm just touching the basics part. Again, we'll do a deep dive on each of these topics as you keep getting familiar with them. Okay, so this is how the text editor is. So graphical editor is just like your text pad that you use in Windows. So you will have a few options available to save, to edit. You can perform all just like you do it in Windows. Okay, so there are some shortcuts that present here. So as you can see, so we'll quickly do some shortcuts. So again, starting from the beginning, so what I did, I'm opening the file in a VIM mode. So use VI or VIM, enter. Okay, so I said that in the beginning we are in a command mode, okay, where we can issue commands. Say I want to go to the beginning of the file, so the line numbers are will start from 0, so it goes to the beginning. Okay, so here if you look at the shortcuts, it says press YY to copy a line. So I'm pressing YY and press P to paste. Okay, maybe if I want to copy 3 lines, I have to say 3YY, 3YY. So here it is displaying 3 lines yanked, means copied. Now press P. I'll put the cursor here and press P. So it got pasted. If I want to paste it multiple times, I just have to say 3P or 4P. It will get pasted 4 times. Okay. Similarly, uh, press D twice to delete. I'm pressing now. So delete it. So if I press DD, a line gets deleted. If I press 5DD, 5 lines will get deleted. Okay, so like that, just go through the shortcuts, just try it once, see how you feel. We'll discuss more in the next module. Okay, you can take any file, or maybe the way I have used it, a man page. Take a man page, redirect it to a file from where you can use that in order for practice and all. Okay, then we have another operator. Okay, it is called as pipe operator. So pipe operator, the way it works is, so basically you are going to take the output of one command and passing as an input to another command. So there are two commands. Okay, so one command, when you run it, it generates some output. Now you are going to pass this output to another command as an input to it. So that is where the pipe will be useful. For example, cat uh, okay, so when I do ls, it is displaying a lot of files, right? Now I can keep a pipe. Then what happens, the output of ls will be passed as an input to another command. So whatever command I use, say for example, there is a file command called grep that will help me to search for specific files. So from the output of ls, I'm passing it to grep, okay, and I'm telling grep to pull all the file names that start with word hello. Okay, so from the output of ls, so it is printing all the file names. I use another command called grep, and I say to this output, grep means search for a word called hello in all the file names and print the output. So grep hello, it is printing all the output on the screen. Okay, so this is how we use a pipe operator. Again, we can, like that, you can again pass the output of the second command as an input to another command. Say grep, again whatever the output that previous command gives, grep for a word called new. So out of this total output, we filtered it using grep. We searched for a specific word, some output came, again we put a pipe and search for another specific word. So like that we have filtered this entire output using the pipe symbol. So this is how a pipe command is used. Okay, this is just an example. There are other examples as well on the screen. You can check those examples as well. we'll be using all these operators throughout the course. Okay, and we have this topic of redirection. Okay, so before moving into that topic, so let me help you explaining about targets. Okay, so I've used the word called mode, graphical mode, non-graphical mode, right? Similarly, uh, so you can consider this as a synonym. Okay, so I'll from now on I'll be using the word called target. Okay, so in system, if you type a command called run level, so it says run level 3, okay, which is a non-graphical mode, or it is also called as a multi-user mode. Okay, a multi-user target. So when you start your system in this particular target, okay, so here you will not have graphics, but multiple users can log in and work in the system. Okay, so it says equivalent to run level 3. So that's what I showed you here, right? Similarly, if you start your system in a different target, say graphical target, then your run level is 5 and you will have all the graphics present in your system. Okay, and then similarly we have a different target or a rescue mode, an emergency mode. Okay, depending on the target. Okay, limited depending on the target, the system will decide what processes have to be started and what not. So when I'm using multi-user target, the system will not start the graphical services. Okay, similarly, if I enter into a rescue mode, the system may not mount everything, or it might uh, create the file system in a read-only mode. Okay, so like that, all these features are segregated, they're separated into different modes, so that depending upon the requirement, we switch to that particular mode and make use of the services. Okay, so this is the command using which we define whether you what mode you want to start to and what should be the permanent state of your system. So if I want to check the current mode, so the command says systemctl get default, so it will say I'm in the multi-user target mode. Okay, similarly, if I say set default, okay, and I am going to choose, see here, I have just typed grep and press tab, it will complete the line for me. So if I choose enter, so what I have done now, I have set the default target to be graphical mode. So if I restart my system, it will start in a graphical mode now. Got it? Similarly, I need to, if I want to change it, I'll say uh, multi-user dot target. Now I have reverted back the change. So this is like permanently making a change in your system. Okay, changing the target. So how different are these two? So in a graphical mode, when you start your system in a graphical mode, the graphical services will be enabled. Okay, so there is a command called start X. So even if you are in a non-graphical mode, if you want to start the graphics, so this is what I'm telling you, just to make you get a feel of the graphical service. So it's a service which can be separately triggered. Start X, the system will start the graphical services for you. So even if you are in multi-user mode, non-graphical mode, you can start your graphics separately. Okay, so it will get started in a second. So this is what the different targets are about. So they are uh, represented using a number also. It says 3 and 5. Okay, and you can also pass these numbers as an argument in order to switch to these targets. So we have the process called init, and you can pass these arguments to init in order to switch from one mode to another mode. So these are some of the examples that you can use of. when switching between these modes. So meanwhile this see, when I did start X, so it is starting the graphical service. Okay, so let's see, there are some questions from Annie. Let's go through these questions and see like how you have understood so far. Okay, dash is responsible for the initial kernel load at the boot time. So we have four options. So kernel, the second one is root, third one is run level, the fourth one is grub. Let's see how many people can answer this question. How many people can tell the right answer? Okay, I have got answers from three of the participants so far. I'm expecting others to participate. All right, so most of the people have given the right answer. It is the grub that is going to load the kernel. All right, so uh, as a part of the booting stage, that's one of the important stage. Okay, well, that's pretty much we have in this module. Perfect. You see, I have started. So this is your the graphical mode. You have started your system in a graphical mode. So I was a root user, so it did not ask me credentials. Okay. So when you log in a graphical mode, so this is how your system would look like. So you can, this is your desktop. You can browse through the applications. Okay. So all the user-friendly apps that you have, and you also have places, home, documents, music, pictures, and you can do a right click, open in terminal. In graphical mode, uh, you can open the same command prompt by saying open in terminal. Again, you're back to the same place. So ls pwd wmi, you can run all the operations here. Okay, so here the advantage, other advantage is you can open multiple terminals. Okay, and if you remember the slash dev folder for which I was explaining before, that contains device related files, right? It also contains slash dev. There are a lot of TTY files. They represent the terminals that we are opening here. Okay, so basically we are interacting with these files. So this is slash dev pts1. This is slash dev pts0. If you open multiple terminals, so each terminal is nothing but file in the slash dev directory. Okay, so this, I hope by now you clearly understood that everything in a Linux system is a file. Okay, so just go through the video. I know that since this is a first class, you might have a lot of content to remember, to cross check again, to practice. Okay, but come up with questions. All right, so we'll spend some time for discussion. We'll have breaks in the middle to discuss on the topics that we have covered. Once you start picking up things, once you get familiar with the topics and all, we'll slowly increase the pace with which we are going. So we'll take it slowly. Okay, so practice, try to do the installation. We have the document available, do the installation, and practice all these basic commands, go through the man pages and go through the entire system, see how files are organized, try running some of these commands, okay, and also just go through the boot process, the architecture part. So if you want, we can I can repeat those topics again. All right, so it will give you a solid strength in the beginning to learn the system, to have a good understanding. So we'll try to spend a little more time in those areas so that we'll be very clear with those topics as well. All right, so let me see if you have it's question time. I'm hoping that uh, you at least have some questions. I'm waiting for your queries. We are done with uh, the topics that are in module 1. Okay, I have a question from Vijay. So he's asking about the init command that I have mentioned before. Yes, Vijay, I have mentioned about the init command. So I have used the word init twice. So once uh, I've used init stating that init is the grandparent of all the processes running in the system. And I've used the second time to say that uh, for every target, there is a numerical representation. So multi-user target is 3, graphical target is 5. Like that, we have a lot of targets in the system. Okay, so now I am in, when I say run level, it says 3, right? So if I want to start in a graphical mode, so by default, the system has been set to start in run level 3. But if I want to start my system in run level 5, I can give init space 5. So init is the grandparent. So to that process, if I say init space 5, it will start the system in a graphical mode automatically. So this is like a temporary change. Okay. Again, if you restart, your system will be in a normal multi-user mode. Similarly, you can say init space 0. 0 indicates shutdown. Init space 6, it means restart the system. So if you give init space 6, automatically your system will get restarted. Like that, all these targets have a numerical representation. It's a very good question, Vijay. So we pass these numbers to init, and you can try all these options that I have given you now. Okay. All right. So who has got the next question? Yes. So there is another question from Priya. She is saying that the files that I've showed here are different from the TTY type. Yes, Priya. So they in turn represent those files. So there are some examples in the second module. I will give you some more examples on the terminal types as well, and with those examples you'll have a better understanding like how the data flows in between these two terminals as well. Okay, for now just remember that. So my intention is just to tell you that everything is a file, everything is represented as a file. Okay, just remember that. I'll come up with more examples for you. So we also have another module where we talk a lot about these different types of files. Okay, so all those topics will be covered there. Then I'll give you more examples on that. Okay, and okay, so this question, so we have another question. So uh, it is about the installation process. So I mentioned that if you have, I suggested, I mean, my recommendation is at least you have 1 GB of RAM allocated, so that the installation process basically happens in a graphical mode. So there is also another way of doing the installation, which is non-graphical mode. So if the RAM is not sufficient, the system cannot start the graphical applications to continue with the installation. So even during the installation, you see the mode is graphical mode, right? We don't issue the comments, we use the apps, we just click English language, click on something else, and we proceed with the process. So if your RAM is not sufficient, the installation will progress in a non-graphical mode, where you have to, just like your command prompt, you have a black screen where it will ask you to manually give your inputs. Okay, so you can also try doing the non-graphical installation. It will be a good practice for you. So these are two different types of installation processes that we have. Other than this, we also have network-based installation, kickstart installation. We'll cover these topics later. Okay, so it's another good question. Appreciate. Come on. All right, so any other questions you have? Okay guys, so we're running out of time. We are done for the day. So we have covered a lot of topics. I hope you all have learned something. You have enjoyed the session. Um, please practice and come up with questions. Okay, and we'll see a lot of new things in the coming session as well. Okay, and I once again request you all to provide your feedback. So what you have liked, what you have not, so that we can make this session much better. Okay, and please come up with your questions. We'll have the second module covered tomorrow. Okay, and that's all for today. So thank you so much for attending today's session. Have a good day. Bye bye.